science. Today we're going to do some kinematics with a little dynamics thrown in. Jason Kessman is here to help us. Jason, why don't you help us out?
Okay, well say you have a car starting at rest, which means you have a VI of 0 meters per second. So say it takes the car 4 seconds, 4.9 seconds to get from point A to B, and it has a VF of 30 miles per hour.
So if we convert that, it'll be about 13.4 meters per second.
13.4
Good job, Noah.
Thank you.
meters per second.
Okay. So from there, we're going to try to find the acceleration. Okay, so we'll use the equation VF equals VI plus AT. Now, so if we make our substitutions, VF equals 13.4 miles per hour. Meters per second, excuse me. 13.4 meters per second. Make sure you're writing the units. Plus, equals, VI is, of course, 0 meters per second.
Starting speed.
Yeah. 0 meters per second.
You don't need that if you want
Now, you need units. You need units. Come on. All right. Acceleration, obviously A, we don't know. So we're writing A. And T we have is 4.9 per second. So if we're going to calculate this, it's 13.4. Okay, obviously.
So acceleration shall equal 13.4 meters per second divided by 4.9 seconds.
And that should equal about 2.73 meters per second squared. And that's your final answer.
That's your acceleration.
Alright, so we're going to do some more kinematics. Alright, we got Max Rocklin here to help us this time. Bit of an upgrade if I say so myself. Alright, so let's about the givens. Alright, so we got our final velocity, which is 0 meters per second because it comes to a stop. So I'm going to put that down. Our initial velocity, which is 20 miles per hour. And if you convert that, that'll equal 8.9 meters per second. And our time is at 9.2 seconds? 7.2 seconds, excuse me. And that's it. So now we're going to find acceleration. Alright, so we'll use the same equation this time. VF equals VI plus AT. Let's fill this out. So VF is 0 meters per second. This comes to a stop. VI, we got 8.9 meters per second. We don't know the acceleration, and the time is 7.2 seconds. So, subtract the 8.9 meters per second. So negative 8.9 equals A times 7.2 seconds. And when you divide negative 8.9 divide by 7.2, you get negative 1.24 meters per second squared. Because it's decelerating. That's why it's negative. Okay, so we're going to do some more dynamics. Got Jason Keshner back here again. He's going to help us find the centripetal force. So first to do that, we're going to have to find the centripetal acceleration, or AC.
Okay, so the acceleration for AC is equal to velocity squared over r.
So now let's fill in the givens.
So our velocity is
12 miles per hour.
12 miles per hour.
Which, if you convert to meters per second, gives you 5.4 meters per second.
5.4 meters per second.
We got our r, the radius of the circle, is 51 feet.
51 feet.
Which, if you convert to meters, give you about 15.5 meters. So now, we're going to put those into the equation. So
you get
AC
is equal to 5.4 meters per second squared over
radius
15.5 meters.
And that'll give you,
which is AC, is equal to
calculations are
Approximately.
correct, 1.9 meters per second squared is your final answer.
Your final answer,
Yep.
Noah. So your AC is equal to 1.9 meters per second squared.
So now that we got that, let's move on to centripetal force,
So
which is FC equals MAC. So, according to Land Rover, the mass of their car is 3,100 kilograms. Plug that in. M equals 3,100. And we found our AC, which is 1.9 meters per second squared. So 3,100 kilograms times 1.9 meters per second squared should give us about 5,890 newtons.
say that again. 5,890
newtons.
newtons.
Oh, that's a lot of force right there. All right,
That is
and
your-
that's your centripetal force.
Thanks, guys.
Yes!